All right, well, welcome back to the study guide for Unit 3, Topics 3 and 4. Okay, so we left off on Section 2 with verifying trig identities, and now we're going to continue with Section 3, okay, which is a problem related to the law of sines and cosines, okay? So for this question, I'm just going to go ahead and read through it. So in triangle ABC, they give us the following measurements. So first I'm going to draw a triangle. It does not have to be to scale, right? As long as we put the correct measurements in the correct locations and we're consistent throughout the problem, we'll be good to go. So they give me that B is 56 degrees, okay? Right now, if you have your graphing calculator, make sure you're in degree mode, since they're giving us measurements in degrees. Then they give me side B, which remember is directly across from angle B. And then they say side A, which is directly across from angle A, is equal to 14. Okay, so what they're asking here is they're saying explain why there are two possible triangles should all work. So immediately when you hear that, you need to be thinking about, or a red flag should go up in relation to the law of sines and specifically the ambiguous case. Okay, so related to the law of sines, I know the angle B and the corresponding side of B, so I'm actually going to use angle B and side B, and then I don't know angle A, but I know side A, so what I'm going to do is set it up for finding angle A. Okay, so I'm looking for angle A. Right? We don't know what this is. Okay, and the law of sines says sine of A over side A is equal to sine of B, angle B, which in this case is 56 degrees, divided by side B, which is 13. Okay, and then I'm just going to go ahead and solve this. Again, make sure you're in degree mode for this next part. So we have sine of A is equal to, and all of this I'm going to put in my calculator, okay, which is going to give me I'll just round it off to the nearest, we'll do 4 spots, so 8, 9, 2, 8, right, so 0.8928, okay, and then the problem is I'm not interested in sine of A, right, I'm interested in angle A, so I'm going to do, I'll make this approximately 2, I'm going to do sine inverse of both sides, right? So that is how you find an angle. So if I do sine inverse of 0.8928 in my calculator, again in degree mode, I get approximately roughly 63.2 degrees, okay? So that is definitely an answer for angle A. We use the law of sines correctly. So there's an answer for angle A. But now in relation to this specific question, they're saying there are two possible triangles. So if you look at this triangle, I have been given an angle side, or in other words, side angle, which if you recall from geometry, that does not guarantee that there is a unique triangle with these specific measurements, right? In other words, and in this case, there is a second triangle, right? So keep in mind angle side, side angle, right? For these, we're going to have to check for what's called the ambiguous case, okay, which means it could go either way, right? There's going to be possibly two answers, and in this case there are, because they're saying that I need to show there are two possible triangles. So I'm going to do the ambiguous case on the next page here, okay? So to find that, if you recall, 63.2 degrees is an acute angle, so I'm going to find the obtuse angle by doing 180 minus 63.2 degrees, okay, which is going to give me 116.8 degrees. So I'm going to put this in dash marks for now, because I need to confirm that that is a second possible value for the angle A. And the way I do that is I now take 116.8 plus the original angle they gave me in the problem, which was set, which is 56 degrees. Okay, so plus 56 degrees, which is equal to 172.8 degrees. That is less than 180 degrees, which is a good sign, because that means that I still have room to squeeze in that last angle C if I wanted to find it, right? So I have two angles that add up to less than 180. A triangle should add up to exactly 180. So I still have room for that last triangle, which means that this definitely is a second answer, okay? And this would be enough to show that there are two possible triangles, right? You just found two possible values for this angle A, which would give two different triangles, right? So these measurements would be the same for each triangle. With the angle A here, you'd have one triangle that has an acute measure of angle A and one that has an obtuse measure, okay? Okay, so there is question 3 for you, and I'm going to go ahead and move on to section 4, to our last section, which revisits the idea of trig equations, okay? Okay. Now, for some of these, there's two ways to do it. So if you look at this, this is actually an identity that we know, right? So if you go to your formula sheet, this guy here is actually on your formula sheet, and that is equivalent to cosine of 2x. So I can substitute that, and now I just have this equation to look at, right? Another way to do it, which might be tempting to do as well, is to subtract the 1 over here, divide by -2, take the square root of both sides, consider the plus or minus case, right? You could do that, but you can see here, this might be shorter, or at least slightly shorter, using this substitution. So remember on your trig cheat sheet, this is equivalent to this. So I'm just going to go ahead and do that right away. And now I have something that's kind of similar to what we did on the first video, right, in section 1 related to trig equations. We had one that was cosine of 3x, this is cosine of 2x. So now I'm going to go through the same process here, and I'm going to say, okay, well, first step, where is cosine of just x equal to 1/2, right? So if you go on the unit circle and you find those, you will see that the two angles are pi over 3, which is in quadrant 1, and 5 pi over 3, which is in quadrant 4, which is no surprise because that's where cosine is positive, right? So we should expect it to be in those two quadrants. And then I'm going to do my second step, which if you recall from the last video, was to find the period. Okay. So again, the period formula for cosine is 2 pi, and equivalently for sine is 2 pi over the absolute value of b. In this case, b is 2. Okay. So the period here would be 2 pi over 2, which is just pi, right? So now I have the period. And now I need to go back, again, reflecting on what we did in the last video. I need to update these answers and say, okay, well, wait a second. I'm not interested in just x, right? I have a 2x here. So I'm going to go and I'm going to say, well, 2x equals pi over 3, and 2x equals 5 pi over 3. And actually, there's a slight error here. I'm sorry if I confused you. Hopefully I read it correctly. If I didn't, this should be a 3. Okay. Let's see if I can get the, won't be quite the same color, but that's okay. So I have the 5 pi over 3, right? So a good thing I caught that. And now I'm going to go ahead and divide by 2 on both sides, which is equivalent to multiplying by 1/2. So I get pi over 6 divided by 2, which is equivalent to multiplying by 1/2. Get 5 pi over 6. Okay, and I'm going to keep my answers up here. Okay. Now, one big difference with this is that they say they use the wording "find the general solution," right? So they're trying to get me to represent every single answer that could ever exist, right? So the way that we do that is we use the combination of these answers I just found and the fact that we know the period of this. Okay, so I'm going to say, well, one answer can be represented by using this first answer, pi over 6, right, plus multiples of this period here of pi. So the way that we usually use that is sometimes you'll see m, sometimes you'll see n. I'm going to use m. Okay, so I'm going to say plus multiples of pi, or m pi, where m is an integer. Right? I'll just make a note of that. So m is an integer, so -1, 0, 2, 3, anything not a fraction, right? And let me just box these off here. Okay. So I'm going to go ahead and now do the exact same thing, but for the second answer to make sure I cover all the cases, and just do 5 pi over 6 plus multiples of pi, again, where m is an integer, right? And so now I've represented every single possible answer that could ever exist by adding these kind of, in general, multiples of pi, or the period for this type of problem. Okay, so there's question 4a for you. Okay, and we're going to go ahead and finish this video off with 4b, which is also a trig equation. Okay, so this one's kind of interesting. If you look at this, I kind of have something that I need to really consider the approach I'm going to use for this, because I don't have anything that I can really factor here, right? There's nothing I can factor between these two. And I would have to set it equal to 0 anyways to do that, to use the zero product property, right? But actually, if you go back to your formula sheet, we also know that this guy here is the double angle formula for sine, right? So this is actually equivalent to sine of 2x, which again simplifies my problem similar to the last one, right? So you can see how it's useful to know these different identities, and again, it's nice that you have the formula sheet there with you, so if you see something that looks familiar, you can double check and say, oh yeah, I know that, for example, 2 sine of x plus sin of x is equivalent to sine of 2x, right? So I'm going to go through my steps here again, just like in the last problem. Remember that they're asking for the general solution. So first, I'm going to find, well, okay, well, where is just sine of x equal to negative root 3 over 2, right? So there's two angles for that. They should be in quadrants 3 and 4 where sine is negative, and that's going to be 4 pi over 3, okay? And then also we have 5 pi over 3, right? So quadrant 4 angle there for you. So after that, we do our next usual step for these types of equations. I'm going to find, okay, well, what is the period, right? Remember that for sine, it's got the same formula as for cosine, so 2 pi over the absolute value of b, where b in this case is 2, okay, which was actually the same kind of setup here, right? B was also 2 for cosine, so this problem is actually going to have the same period, right? It's going to be 2 pi over 2, which again is pi. So I see that same period show up for this sine equation, right? Okay. So now I'm going to go back and I need to revisit these answers and say, oh wait, I didn't want just x, right? I want 2x. So now I go back and I say, okay, well 2x equals 4 pi over 3 and 2x equals 5 pi over 3, right? So I'm going to solve for x by dividing by 2, which is equivalent to multiplying by a half. Okay. So here I'll get 4 pi over 6, which is equivalent to 2 pi over 3. Okay. I'll just kind of keep those separate so we don't get confused. Divide by 2, equivalent to multiplying by a half. This one I get 5 pi over 6, right? So now I kind of have my updated, if you will, answers, and they want the general answer, so I'm going to use the exact same setup as in the last problem, and I'm going to say x equals 2 pi over 3 plus multiples of the period, which in this case was pi again, so plus m pi, where m is an integer. Okay, and then we have the second sort of set of answers as 5 pi over 6, right? Again, plus multiples of pi, where this m is just an integer. You can pick any integer you want and you'll get some of the answers, right? So there we have the final answers for this equation, okay? And again, we've represented every single answer possible by having this general form, right? So anytime I say general solution, you're going to have some sort of a multiple of whatever period you're looking at for a given equation, okay? So that concludes the study guide for Unit 3, Topics 3 and 4. I hope it was helpful, and thanks for watching.